Hello everyone, welcome to come back. Now we're going to start our first experiment, and in this experiment we're going to use this board to drive or to control the first LED diode. And in this test we are going to involve in two parts, I think. The first part is we're going to try to light up the first LED, and the second part is we're going to apply a time delay function and to light up and then extinction and then light up and then extinction first LED with an interval. But obvious this interval is controllable or is programmable. You may ask me why I placed a multimeter here, because in this test we're going to involve calculation. So I think probably we can measure the voltage drop right now, and this measurement will be used for the calculation later on. So as you can see, when the first LED is conducting, the voltage drop on the LED is 1.8 volts. 1.799, so we call it 1.8 volts. But when it's extinguished, the voltage is 0 volts. So let's just remember that value, 1.8 volts, and we're going to use this value just slightly later. And this is the program, so which has been done. I will come back to this program and to explain to you each individual sentence and to explain how it works. But before that, I would like to show you the electrical schematic drawing. I just zoom out a little bit so you can see the whole image. So this is the schematic of our experiment board, and this bit here is the microcontroller. This bit here is a corresponding LED tubes indicator. But for the test we are going to do today, or right now, is located here. So as you can see, it starts with a voltage source VCC. Remember, I told you guys before, this experiment board is powered by the USB port, and the USB port voltage is 5 volts. So here we know the VCC voltage is 5 volts. And this power source will go through a resistor array, and you can see here the resistance value is 1 kilo ohm of each individual resistor. So that resistor will be in series with the LED diode. So totally we have 8 diodes from D1 to D8, and after that, here is a latch. I will explain to you why we need this latch here later. But however, one side of the latch is connected with the LED, and the other side, the DO port, is connected with the first leg of the microcontroller, which has been defined as DB1. And you can see the second leg of this latch is DB1, and the first leg of the microcontroller has been named as DB1 as well. So which means electrically those two legs are connect each other. This is different from our normal electrical schematics. Normally we will show that connection with solid wire, but because the electronic schematics normally is much more complicated, so in most of situations we try to avoid to draw all the wires, otherwise it will be look like a mess, will be very busy. So this is the way we used, at least on this schematic drawing, based on the leg names. So it's DB1, connect with DB1, and also you can say here the analog to digital converter 0804, its leg 18 also connect with the first leg of the microcontroller, which is DB1. Right. So that's the electrical schematic arrangement. Now, what we know based on the theory, if we want the current go through a LED, we have to satisfy two conditions. One is we have to apply a different voltage on the two sides of the LED, and the second condition is we have to have a closed loop. So the first condition we should satisfy as long as we set the DB1 leg is low, because the other side has been connected with VCC, which is high. Just remember, when we talk about digital control, when we talk about high or low, or 0 or 1 or whatever, we always talk about voltage, which can be 10 volts, 5 volts, 3.3 volts, or whatever volts. It depends on your VCC voltage. And low normally means ground, which in the binary world we call it 0. Okay, so if we want to make this circuit, we have to connect the DB1 to ground. So VCC go through the first resistor and go through the LED diode and then connect with ground. Obviously this is a closed loop as well, and then we can light up the first LED. Okay, now that's the electrical working principle. It looks pretty simple. Just a voltage source and drive this LED with a current limitation resistor 1 kilo ohm. So if we simplify this schematic, we can have this circuit here. So basically VCC 5 volts, it's 1 ohm resistor in series with the first LED, and goes through a latch. The latch can be deemed as a switch, so I just use a switch for time being to represent that latch there. So the reason why we need a latch here is because both LEDs and analog to digital converters has been connected with the first 8 pins on the microcontroller. So when we are working on the analog to digital conversion test, we don't want that test will come back to impact the LED indications. So what we need to do is we're going to disable this latch, which basically means we're going to open this switch. So in that case, regardless what's the status on this side, there will be an open circuit, so the LED will be permanently off when we are working on the analog to digital conversion test. So that's really why we applied this latch here. And the state of this latch is controlled by this pin here, which is leg 11. So it has been connected with DIOLA. If you can say here, so this is DIOLA, which is P25 on the microcontroller. Okay. Now, as I mentioned before, we in this test we're going to involve a little bit calculation. 5 volts, and we have measured the voltage drop on this LED is 1.8 volts or 1.7 volts. That was the result I had in my other test boards. But however, if we apply the Ohm's law, we know 5 volts minus 1.8 volts and divide by this resistor here, we will end up with 3.2 or 3.3 milliamps, and that's the current actually goes through this LED diode. And we know normally minimum current requirement 3 milliamps is required to drive this LED. If the current is too low, we probably can't drive it, but if it's too high, maximum is about 20 milliamps, but if the current is too high, we will damage the LED. So we try to limit the current within 3 to 20 milliamps, and based on the calculation we have 3 point something milliamps right now. And also one thing I would like to point out is, remember the current on the LED and the voltage across the LED is not linear. So in other words, you can't use Ohm's law to do the calculation between the voltage and the current of LCD. So if you go back to the basics of electronics, and you should be able to see the characteristic between the voltage and the current of LED. Okay, so that's the procedures we have to apply. Based on the voltage on the LED, use the voltage source minus that voltage drop and divide by the resistor. Because we can apply Ohm's law for resistor, the voltage and the current is linear. So, okay, that's the calculation. Now, from the control point of view, it is obvious what we actually need to do is to try to control this port, because this port is permanently connected with 5 volts, and this port is connected with the I/O port of the microcontroller. So as long as we can set this leg of the microcontroller is ground, and then this LED will conduct it. But if this point is 5 volts, and now because the two sides of the LED both are 5 volts, so there's no current flow through. So that's our target. We will try to set this point as ground or as 0, and that is controlled by our program, which is here. So if you have looked at the structure of this program, you should be able to see we should start with the main function.